In this video, I'm going to show you how we can use the basic trigonometric identities for simplifying trigonometric expressions. Here you can see a list of trigonometric identities. Pythagorean identities, which this one is the most famous one, sine to the 2 plus cosine to the 2 is 1. And other Pythagorean identities. Reciprocal identities. Cosecant is 1 over sine, secant is 1 over cosine, cotangent is 1 over tangent. Quotient identity. Tangent is sine over cosine, cotangent is cosine over sine. For example, we use these identities here whenever we have tangent or cotangent, because usually, not necessarily, but most of the time when we have tangent or cotangent, we prefer to write them in the form of sine over cosine and cosine over sine, because we can work with sine and cosine easier than tangent and cotangent. Here in this video, please notice, I'm not going to show you only how to simplify trigonometric expressions. I'm going to show you how I am thinking for simplifying expressions. Because if I only show you the simplifying trigonometric expression, you don't know why I choose this particular method for simplifying. Why I didn't use the other identity or other method. Why I am doing this operation at this moment. So I try my best to show you everything and the way that I am thinking for simplifying expressions. Look at the first example, cotangent over cosecant. For cotangent, if you pay attention, we have two relations here. Cotangent is 1 over tangent, cotangent is cosine over sine. But between these two relations, which one is better to be used here? Because I noticed that in denominator I have cosecant, and cosecant is 1 over sine. What do you think? Between these two relations, which one works better, probably, to simplify this expression? Is it better to replace cotangent with 1 over tangent or cosine over sine? Probably here, this identity, cotangent is cosine over sine, works better, because we can replace cosecant, which is in the denominator, with 1 over sine, and if we replace cotangent with cosine over sine, then probably sine can cancel and we can simplify the expression better. So let's see if this works or not. So for simplifying this expression, we write cotangent as cosine over sine, and we write cosecant as 1 over sine. Then this is the numerator, which we want to divide it by this denominator. To divide these two by each other, we can write the numerator cosine over sine is divided by 1 over sine. This fraction here is basically this. This is the numerator divided by denominator. And we know that for dividing two expressions, we write the first fraction and we multiply it by the invert of the second fraction. We multiply by the reciprocal of the second fraction. Reciprocal of 1 over sine is sine over 1. Now sine from denominator with sine from numerator cancels, and the answer is cosine theta. So the simplified form of this trigonometric expression is cosine theta. But let me show you the better way for simplifying this fraction, this compound fraction here. Please attention. Let me show you two different methods for simplifying this expression here. The first thing that you have to notice is that when we have a fraction divided by another fraction, there is a shortcut for dividing a fraction by another fraction. The shortcut is this: d times a, or multiply this by this, multiply the outer terms by each other, a times d, all over b times c. This is a shortcut for simplifying this fraction. If we use this method, then this answer would be, the sine goes up and it multiplies by cosine, so we have sine times cosine over Sine times 1. The sine with sine cancels and the answer is again cosine. But still we have better way to simplify this. These are the things that you need to learn to improve your algebra. Look at this. When we have a fraction, a numerator over a denominator, if the numerator is a fraction, denominator is a fraction, if the denominators are the same, you are allowed to cancel them. And if the numerators are the same, also you can cancel them. So here, because the denominator is the same as denominator, cancel them. What remains? Cosine. So the answer is cosine, which is in the numerator, so the cosine is the answer. You don't need to do anything at all. So as you can see, in one step you can get the answer. So if the denominators are the same, simply cancel the denominators. And also this works for the numerator. Suppose you have a over b all over a over c. Here the numerators are the same. So immediately you can say a with a cancels, and then what happens to b and c? Please pay attention. The c would go up, so c would be your numerator. B goes down, b is denominator. So if numerators are the same, you can simplify them. If denominators are the same, you can simplify them. And finally, as you can see, there are different ways that it's really important to know for simplifying expressions. Let me show you the final way for simplifying this. Whenever you have a fraction over another fraction, and sometimes plus or minus another terms, for simplifying expressions like this, you can multiply the numerator and denominator by some expressions to get rid of denominators. Later in this video, I'll try to show you this method as well. But for this question, this particular question, the best method is to notice that the denominators are the same, cancel them, and the answer is cosine theta. Now look at the next example. Sine theta, secant theta over tangent theta. For secant, we have this relation. Secant is 1 over cosine. So it can be a good idea to replace secant with 1 over cosine. Now look at the denominator. We have tangent. Tangent is sine over cosine. And we don't have any other identity in these identities that here we have. So let's replace tangent with sine over cosine. Look at the numerator. In numerator, basically we have sine theta times by a fraction. Sine theta multiplies by numerator because the denominator of this is 1. So in numerator we have sine theta over cosine theta. What we have in denominator? Sine theta over cosine theta. Look at the numerator and look at the denominator. They are the same. Same fraction in numerators, and this is numerator, the same fraction in denominator. You can cancel these two, and the answer is 1. Don't forget, when numerator and denominator are the same, the ratio is 1. Basically, this happens here. Sine with sine cancels, cosine with cosine cancels, everything cancels, and the answer is 1. So, the simplified form of this trigonometric expression is 1. This expression is always 1. Now let's do some harder examples. A little harder. Sine x tangent x plus cosine x. These two are in terms of basic trigonometric identities, but tangent is not so basic. Tangent is also a basic expression, basic trigonometric function or expression, but we can write it in the form of sine over cosine. Quotient identities are really useful. So here, the first thing that I think can help us to simplify this is sine x times tangent is sine over cosine plus cosine. Now, attention, denominator of this is 1, so multiply numerator by numerator, denominator by denominator. Now we have sine to the 2, sine to the 2 over cosine x plus cosine x, and we can consider a denominator 1 for that. We have a fraction plus an expression. It's a good idea to combine these two. Remember basic algebra, when we have 2/3 plus 1/5, what you do immediately when you see something like this? Common denominator. So if you follow same thing here, we have a fraction plus something. What you have to do? Common denominator immediately. You have to combine these two fractions. To have at least one fraction is better than two fractions. So we combine these two. If we do a common denominator, what is common denominator between these two fractions? Cosine x, of course. So we have sine to the 2x all over cosine x plus denominator of this fraction is cosine x. So we need same denominator for this. So we multiply this denominator by cosine. So 1 times cosine is cosine. Because we multiply denominator by cosine, we multiply the numerator also by cosine. So the numerator would be cosine to the 2. Attention, we multiply denominator by cosine. So we multiply the numerator by cosine. Cosine x times cosine x would be cosine to the 2. Now, we have two fractions with same denominators, as you can see. What is the denominator here? The denominator is cosine x. What is numerator? Numerator is sine to the 2 plus cosine to the 2. Look at the numerator. Do you remember anything for numerator? Sine to the 2 plus cosine to the 2. Whenever we see power 2 for trigonometric function, trigonometric expressions, we have to remember Pythagorean identities. Look at the Pythagorean identities. You have power 2 in them. Power 2, power 2, power 2, power 2. So when we see power 2, we should think to trigonometric Pythagorean identities. Sine to the 2 plus cosine to the 2 is 1. This is very famous and very important for simplifying expressions. So numerator is 1. All of this is 1. So we have 1 over cosine. So the simplified form of this expression is 1 over cosine. 1 over cosine. You can leave your answer in this form, and this can be your final answer. So the simplified form of this trigonometric expression is 1 over cosine. But if you like, this is completely optional. It's not necessary to do this. Remember reciprocal identities? Identities, this should be identities. What has happened here? Identities. 1 over cosine is secant. 1 over sine is cosecant. Here, the answer is 1 over cosine. If you like, you can write this in the form of secant x. If you don't like to see fraction, you can write it secant x. But attention, secant x at the end is a fraction, 1 over cosine. So this is the final answer of this question. We simplify this expression. Now look at the next example. Sine theta over cosine theta plus cosine theta over 1 plus sine theta. Before doing anything, first always we check for identities. Maybe there is a direct identity that we can reuse right away. But if you check here, you can't see any particular identity to replace anything with that. Maybe for a moment you think, oh, okay, it seems familiar and this is tangent. Yes, you are right. But is it a good idea to replace this with tangent? While other things here are trig, are sine and cosine? No, of course not. Because we like to have similar expressions. Sine and cosine can be simplified with each other easier than when we have a tangent with them. So it's not a good idea to replace that with tangent. It can't be a good idea. Maybe you can simplify it with that way, but I think it would be harder. So what we have to do? Remember, when we have two fractions usually, yes, combine them, do a common denominator. So let's see if it works here or not. So here we think to doing a common denominator. What is common denominator between these two expressions? Of course, we have to multiply them by each other. So the common denominator is basically cosine theta times 1 plus sine theta. So common denominator here is cosine theta times 1 plus sine theta. Basically, we multiply the denominator of this with 1 plus sine. So we have to multiply its numerator by also this. So for the first fraction, we have in the numerator sine theta times 1 plus sine theta. What about the other one? For this fraction, we had this denominator. And we multiply this denominator by cosine. So we have to multiply this also by the numerator. In numerator, we have a cosine. And we have to multiply by another cosine. Cosine times cosine is cosine to the 2. So in numerator, we have cosine to the 2. Now, let's simplify the numerator. If we multiply sine in the bracket to simplify the numerator, sine times 1 is sine theta. Then we have sine to the 2. Sine times sine is sine to the 2. And finally, cosine to the 2. And over cosine, maybe you are thinking to multiplying the cosine in the bracket like the numerator. But we do this, we multiply the brackets in numerator. But usually we are not doing this in the denominator. We leave the denominators usually in the factored form. But we simplify the numerator. Because, attention, we prefer to have the denominator in the factored form because we hope that we can find one of these factors in the numerator, then we can cancel that common factor with the denominator. So, usually it's not a good idea. Not necessarily, not always, we don't have a general rule, but usually it's not a good idea, usually I am saying, to multiply these two by each other. If by multiplying this in this bracket we get a simpler answer, yes, it can be a good idea. But if you multiply cosine by 1 plus sine, you would see that nothing would be simplified. So it cannot be a good idea to multiply cosine in the bracket. Now look at the numerator. In numerator, we have sine theta plus sine to the 2 plus cosine to the 2. When we see power 2 on top of sine and cosine, this reminds us Pythagorean identities. And this reminds us 1. Sine to the 2 plus cosine to the 2 is 1. So the numerator is sine theta plus 1 or 1 plus sine theta. Doesn't matter the order. 1 plus sine theta all over cosine theta times 1 plus sine theta. Now look at the numerator. This is exactly this. So this completely cancels with this. So this can be written as 1 over cosine theta, which if you like, you can write it as secant theta. And this is the final answer for this question. Now look at this example. Cosine to the 3x plus sine to the 2x cosine x. We don't have any fraction, so we are not thinking to common denominator. One of the methods basically for simplifying algebraic expressions in general is factoring. Look at these two terms. What do you notice? Cosine is common factor. So we are not sure that this works or not, but we try to see if it works or not. If it doesn't work, we multiply again. Attention, there is no general method for simplifying trigonometric expressions. You have to try different methods to see which one works. But gradually, when you do more and more examples, you get more familiar with the identities, with the techniques, with the tricks. This is the best way that you can learn this, practice different questions. So here, immediately I notice cosine is common. So I'm going to factor cosine x here. If we factor cosine x, then what happens? We have cosine to the 2x, because cosine times cosine to the 2 would be cosine to the 3. We factor one cosine, so if from the first one we have cosine to the 2, and from the next term we have plus sine to the 2. Cosine to the 2 plus sine to the 2 again is 1. The bracket is 1, so that final answer is cosine x times 1 or cosine x. So this is the final answer for this question. Please pay attention. There is no unique method for simplifying expressions. Maybe another person simplifies this in another way. Let me show you, for example, here how you can simplify this question in another way. And sometimes, of course, one method is better than the other one. Let me show you another method for simplifying this. So let's say method 2. Here, my method is this. I'm thinking, okay, let's leave cosine to the 3 here. I notice that I have sine to the 2 here. So, sine to the 2 reminds me, yes, Pythagorean identities. But which one? Of course, this one, which has cosine to the 2. Or sine to the 2, basically, sine to the 2. What was here? Sine to the 2. But maybe you think, but we have no cosine to the 2, and then the sum is 1. Please pay attention. One problem that many people have with this identity is that they think that they can use this identity only when they have sine to the 2 plus cosine to the 2. But basically, this identity can be written in two other forms, and those forms are also very important. Please pay attention. We have this identity that sine to the 2 plus cosine to the 2 is 1. Keep sine to the 2 in the left and move one cosine to the 2 to the other side. Then you have this identity. Sine to the 2 can always be written as 1 minus cosine to the 2. And cosine to the 2 can be written as 1 minus sine to the 2. So, in a question, if you want, whenever you have sine to the 2, you can replace it with 1 minus cosine to the 2. And if you have 1 minus sine to the 2, you can replace it with cosine to the 2. Or if you have cosine to the 2, you can replace it with 1 minus sine to the 2. These are identities that many people forget, and they think that you can use Pythagorean identities only when you have sine to the 2 plus cosine to the 2, and then you can replace it with 1. No. This identity basically is this and these two. And especially in many cases, when we have 1 minus cosine to the 2, we replace it with sine to the 2. When we have 1 minus sine to the 2, we replace it with cosine to the 2. So keep these in your head. These are really, really helpful for simplifying trigonometric expressions. Here, I have a sine to the 2 in my question, so I am going to replace it with 1 minus cosine to the 2. So here in this question, we substitute sine to the 2x with 1 minus cosine to the 2x times by cosine x. Now multiply this cosine x in the bracket to see what happens. Then we have cosine to the 3x plus cosine x minus cosine to the 3x. If you multiply cosine in the bracket, you would get this. Now attention, this cancels with this, and the answer is, the final answer is cosine x. As you can see, the two answers are the same. The methods are different, but the answers at this end is the same. Now look at the next example. 1 plus cosine y over 1 plus secant y. In numerator we have basic trigonometric expression, cosine, but in the denominator we have secant. And usually when we have secant and cosecant, we prefer to replace them with the reciprocal identities. What was secant? Secant is 1 over cosine. So here immediately we write this as 1 plus cosine y, 1 plus 1 over cosine y. So here we use the reciprocal identity. And my reason for that is that in numerator also I have cosine, and it's good idea to replace this with 1 over cosine because secant is 1 over cosine. Now, how we can simplify this? You have two ways to simplify this expression. Again, attention, this is a division. You can say numerator divide by denominator, and for simplifying the denominator you can do a common denominator here, but that is not a good way for simplifying this. Do you remember something that I told you? I will explain later. Here I told you for simplifying fraction over fractions we have a method. Now I want to show you that method. Here we want to simplify this expression. And attention, this is my numerator, this is my denominator. And if you want, you can consider a 1 as denominator for this. The best way for simplifying this compound fraction here is to multiply the numerator and denominator by something that can help us to get rid of this expression, this fraction. Suppose this fraction is not here. Then, if you notice, this is really simple expression. If only this is not here. So, we try to eliminate the cosine y from denominator. How we can get rid of cosine y? Of course, by multiplying by cosine y. So, we multiply the numerator and denominator by cosine y. Maybe you wonder why I have to multiply the numerator by a cosine y. Because attention, you don't want to change the value of this expression. So whatever you do with numerator, you do with the denominator, so that when you multiply the numerator by and denominator by same thing, this is like 1, and multiplying by 1 doesn't change the value of the original expression. So you are not allowed to multiply only the denominator by something. You have to multiply the numerator by that thing also at the same time. Now, multiply cosine in the bracket. Then we have cosine y plus cosine to the 2y. What happens if you multiply cosine y in the bracket? Cosine y times 1 would be cosine y. Cosine y times this cosine with the cosine cancels. We are not going to really multiply. This cancels with this and we have 1. Now please attention to this. When we get to here, maybe we think, okay, it's not simplified. This is even worse than the original expression. This seems a little maybe complicated, more complicated than the original expression. But if you pay attention, we did something bad here. We multiplied this in the expression that here we had. And there was really no reason to multiply cosine in the bracket, because by multiplying the cosine y that was outside of the bracket in the bracket, we got this, which is not really simplified. The reason that we multiply this is that when we multiply, we get a simpler expression. But when we multiply the numerator in the bracket, it's not really simplified. So maybe it's better not to multiply this cosine in the bracket. Leave it outside. So let me erase the numerator. I leave the cosine outside. So 1 plus cosine y times cosine y. Even if you multiply this, again you can factor it and you can get same expression as here. But definitely it's better not to multiply when it is good idea to multiply when it simplifies your expression. When by multiplying you get a more complicated expression, there is no reason really to multiply. As I said in the beginning of the video, I'll try to show you the way I am thinking, the way I am doing this process of simplifying expressions. I'm not going to show you only the solution, because if you look at the solution only, then you get no idea why this process in this particular way has happened. I'll try to show you everything that I am thinking about. Now look at the numerator and look at the denominator. Can you see anything? 1 plus cosine in the bracket. In the denominator we have cosine y plus 1. And cosine y plus 1 is the same as 1 plus cosine y. Because, attention, 1 plus 10 is the same as 10 plus 1. They are the same. So, what we can do here? We can cancel this common factor from numerator and denominator. And the answer is cosine y. Now look at these examples. Cosine x over secant x plus tangent x. Here you can pause the video, try this question by yourself, and then continue watching the video. It can be a good idea to try to simplify this expression by yourself. Cosine x over secant reminds me 1 over cosine. Tangent reminds me sine over cosine. X, why I have written y, I don't know really what's going on here. Cosine x, cosine x. So we have cosine x over 1 over cosine x plus sine x over cosine x. First of all, note that in denominator we have two fractions. But the good news is that these two fractions have same denominator. So we can combine these two and write them as a single fraction. So this equals to cosine x all over 1, which you don't need to write a 1 here, but if you like you can put a 1 as denominator for cosine x. So in numerator we have a fraction over 1 plus sine x all over cosine x. So we have a fraction divided by another fraction. You know that when you want to divide a fraction by another fraction, you write this and you multiply by the reciprocal of this. But if you remember, I told you a shorter way for doing this. What was that method? Multiply this by this, far by far, close by close. Multiply this term which is far from this term by each other, and multiply this expression which is close to this expression by itself, by this. So multiply far by far expressions, close to close expressions. Cosine times cosine, 1 times 1 plus sine. This is one way. The other way is to say, okay, I have a denominator here. I don't like this denominator, so to get rid of this, multiply this by cosine x, multiply the numerator by cosine x. Then this cosine with this cosine cancels, and cosine times cosine would be cosine to the 2, which is exactly the same as saying multiply this by this. So as you can see, different methods finally give you the same answers. It's up to you to choose between these methods, or even you can use the method that already you know. Divide this by this, which means that multiply this by the reciprocal of this, but that way is really a slow method. So here immediately I am saying this multiplies by this. And let me remind you something. Suppose we had a cosine x here. Forget this. Suppose we had a cosine. What you can do, you can simplify this with this, because denominators are the same. But if a numerator is the same as a denominator, no, you cannot do anything with that. But if denominators are the same, you can simplify them. If numerators are the same, you can simplify. For example, suppose we had this 1 plus sine here, then we can simplify that with this also. So let's continue. What's happening here? We have to multiply this by this, and we have to multiply this by this. So finally we have cosine times cosine, which is cosine to the 2. 1 times 1 plus sine is 1 plus sine. Up to here, we simplify this expression maybe a little, but not significantly. Do you have any idea here to simplify this? 1 plus sine it doesn't seem so much familiar. We don't have any relation for that. We don't have anything to substitute for that. But look at the numerator, cosine to the 2. Cosine to the 2. Does it remind you anything? Cosine to the 2, sine to the 2. Do you remember sine to the 2? Plus cosine to the 2 is always 1. Do you remember that? But this is only cosine to the 2. And if you remember, I told you this is really, really important. Cosine to the 2 can be written as 1 minus sine to the 2. And why we have to think even to this? First of all, we have a cosine with power 2. This is one reason, the first reason that you have to think about this. The other reason is that, look at the denominator. What do you have in the denominator? Sine, 1 plus sine. So, this can be another reason to think about that. So, let's replace the cosine to the 2 in the numerator with 1 minus sine to the 2. And in the denominator, we have 1 plus sine. Now here you have to remember one of the most important identities in algebra. A to the 2 minus b to the 2 is a minus b times a plus b. Hopefully you remember this identity. The difference of a square's identity. A to the 2 minus b to the 2 is a minus b times a plus b. So let's use this identity for numerator. 1 minus sine to the 2, which is 1 to the 2 minus sine to the 2, can be factored as 1 minus sine times 1 plus sine. And look at the denominator, 1 plus sine. This cancels with that. These two cancel each other. So the final answer is 1 minus sine x. This is the simplified form of this expression. 1 minus sine x. Now look at this example. Sine to the 4 alpha minus cosine to the 4 of alpha plus cosine to the 2 alpha. We want to simplify this expression. This is a little tricky question. Look at these two terms. Both of them have power 4. And between them is minus. Again, this should remind you this identity. A2 minus B2 is A minus B, A plus B. And the reason that you should remember this is that you have even powers and the minus between. This is not really a simple example. This is a little advanced example. So if you cannot simplify this right away by yourself, it's completely normal. Sine to the 4 minus cosine to the 4 can be factored in the form of sine to the 2 minus cosine to the 2 times by sine to the 2 plus cosine to the 2. And we leave that extra cosine to the 2 here. Let me explain a little what happened from here to here. This is for us like a to the 2. And this is like b to the 2. The factored form of a to the 2 minus b to the 2 is a minus b, a plus b. But why a is this? Because a to the 2 is sine to the 4. So a would be radical or a square root of sine to the 4. A square root of sine to the 4 is sine to the 2. A square root of cosine to the 4 is cosine to the 2. And this is the way that you can factor this expression here. Now look at the brackets. One of the brackets should be familiar for you. Sine to the 2 plus cosine to the 2 is 1. So this bracket is 1. And 1 times by anything is that thing, that expression. So we have only sine to the 2 minus cosine to the 2. Attention, again, this is 1 times by this would be this again. And don't forget that cosine to the 2 at the end. So plus cosine to the 2. Cosine to the 2 alpha. This minus cosine to the 2 with cosine to the 2 cancels, and the final answer is sine to the 2 alpha. Now look at these examples. Secant alpha over sine alpha times tangent alpha plus cotangent alpha. It should be clear for you that right away we are going to replace secant with 1 over cosine. Sine alpha is sine alpha. We don't do anything with that. Tangent is sine over cosine. Cotangent is cosine over sine. Now how we can simplify this expression? Of course, there are different ways to simplify this expression. For example, maybe you are thinking to add these two to each other, do a common denominator, then multiply sine in the bracket, then do the division, divide this by this. Maybe some of you are thinking about first multiplying sine in the bracket, term by term, because if you multiply sine in the bracket, for example, this sine with this sine cancels, and then you have an only cosine alpha. That can be a good idea, so. And then divide the numerator by denominator. As you can see, there are different ways. There is not a unique approach, a unique method to simplify this. It's completely up to you to choose between these different methods. Or even maybe you prefer not to do any of these. You prefer to get rid of this denominator, and this denominator. And how we can do that if we want to do that? We have a sine and a cosine denominators, as you can see. So we can multiply all of the numerator and all of the denominator by sine alpha, cosine alpha. We multiply the numerator and denominator by sine alpha, cosine alpha. Attention, if you multiply this in this cosine with cosine, if you multiply this by this, sine with sine cancels. So this is another way. But if you pay attention, definitely this is a good idea. But if you pay attention, before doing that, if we multiply the sine in the bracket, this sine with this sine cancels, and only we have a cosine in the denominator, then we can multiply the numerator and denominator only by a cosine, and we can simplify the expression. So let's multiply the sine in the bracket, then we do multiplying numerator and denominator by expression, by an appropriate expression. So we have 1 over cosine all over sine times sine is sine to the 2 alpha over cosine alpha plus sine alpha times by this sine with sine cancels, and we have a cosine alpha. Now by looking at the numerator and denominator, we notice that in numerator we have a cosine in the denominator. In denominator also we have a cosine in the denominator. So it can be a good idea to multiply the numerator and all of the denominator by cosine alpha. What happens by this? If you multiply the numerator cosine alpha times by 1 over cosine alpha, this completely cancels with this, and in numerator we have only 1. Now look at the denominator. When we multiply cosine by this, cosine with cosine cancel, and we have sine to the 2. And when we multiply cosine alpha by cosine alpha, we have cosine to the 2 alpha. Look at the denominator. Sine to the 2 plus cosine to the 2 is 1. So this equals 1 over 1, which is 1. Now look at the next example. 1 over 1 minus sine plus 1 over 1 plus sine. Two fractions. And immediately we know that what we have to do. When you see fractions, what you do normally? Common denominator. You have to add fractions to have only one fraction. Usually this is the best way that we can start doing this type of questions. The common denominator is 1 minus sine theta times by 1 plus sine theta. This is the common denominator. This is one denominator, this is completely different denominator, so we multiply them, and this is the common denominator. This is the least common multiple. Because we multiply this denominator by this expression, so we have to multiply this in this numerator. So for the first fraction, in the numerator we have 1 times 1 plus sine, which is only 1 plus sine. For the next fraction, plus, we have a plus, plus We had this denominator here. We multiply the denominator by this, so we have to multiply this numerator by this. 1 times by this is 1 minus sine. So in numerator we have 1 minus sine theta. Now if you look at the numerator, sine and minus sine, they cancel each other. And in numerator we have only 2. So this term with this term cancels. And in numerator we have 2 over 1 minus sine times 1 plus sine. You can leave it like this in the factor form. But if you multiply 1 minus sine by 1 plus sine, what would be the answer? A minus b times a plus b. The answer is a to the 2 minus b to the 2. If you remember the identity, a minus b times a plus b is a to the 2 minus b to the 2. And because by multiplying the brackets by each other, we get a simpler expressions, we get a better expression, it's a good idea to multiply them, not to leave it in the factor form. So we multiply the brackets in the denominator. Usually this is not something that we do, but if we multiply them by each other and we get simpler expression, why not? Let's see what happens. If it's not a good idea to multiply, then we write it in the factor form again. But let's multiply them. 1 minus sine times 1 plus sine is 1 minus sine to the 2. When I write 1 minus sine to the 2, immediately I remember something. What is that thing? 1 minus sine to the 2 is, yes, it is cosine to the 2. If you remember, 1 minus sine to the 2 is cosine to the 2. 1 minus cosine to the 2 is sine to the 2. And of course, this answer is definitely better than this answer. And finally, if you like, you can write this final answer in the form of 2 secant to the 2 theta. Because 1 over cosine is secant theta. When you have 1 over cosine to the 2, is secant to the 2. So 2 over cosecant to the 2 is 2. The 2 is here still. And cosecant to the 2, because it's in denominator, it can be written as secant to the 2. And this is the simplified form of this trigonometric expression. I hope by watching this video you have learned about simplifying trigonometric expressions with basic trigonometric identities. Here in this video, I'll try to show you the process of thinking, at least the way that I am thinking for simplifying trigonometric expressions. I hope that this video was helpful for you. And if it was helpful for you, please subscribe in my channel and see you in the next videos.